When we look into a layman term of inherit, right? So inherit is referring to a movement or accessibility of one property from the generations, right? So when we speak about the generation here, there'll be grandfather, father, and son. So how will the property move? The property, we can't say property is moving, but we can say who can access it. Grandfather's property, he can use it, he can access it. Next comes the property, the father, who actually is one of the guy who can use that property or access that property. Similarly, a grandchild or a son can also be accessing it, right? So that's how a property moves or a property flow happens. So in Java, not only in Java, we had this property in many languages. So the first one is where we have it in C++ also, where C++ is also working on the property of the pillar of inheritance, right? Inheritance is also called as a pillar of object-oriented programming. So here, as I said, there'll be a parent and a son, where a parent can access it, even the child can also access it. So whenever a child is accessing that property or those information, so here property in Java is instance variables and member variables and member functions. All right, member variables and member functions. If you want to access the information, even though it is private, then it should be inherited. All right. So many topics came here. We spoke about the concept of public access specifiers, private access specifiers we saw. So even that concept comes and resides here. All right. So yeah, we'll move here. The inheritance is one of the pillar of object-oriented programming. It allows the creation of hierarchical classifications. So what do I mean by hierarchical classifications here? So hierarchical classifications refers to, as I said, I have a grandfather, and grandfather's information or the property will be moving on to the father, and from father it automatically moves to the son. Okay, so these are the property, or this is how exactly inheritance work. Anybody would like to tell me with any more examples? Can you try giving me much more examples of this? I guess you people might have not studied anywhere in your lower semesters, because yeah, if there is a computer science student, he might have studied, as we have multidisciplinary students here, so the chances are very less. So if in case you have understood with any of these concepts, can make an attempt to make an attempt to tell me how exactly it is. 1 minute, I'm just connecting my stylus. Okay, so inheritance is one property, as I said, where I have a grandfather. So here grandfather, in terms of technical, we call it as a superclass or the base class also. Okay, so what is the property of the base class or the superclass? This is where it starts. All right, so that's exactly where the thing starts. Yeah, so that's why you call it as a superclass here. So as you can see, the superclass, and under the superclass we have the subclass. So with the example here, you can see that this is a grandfather. Okay. So here we have the grandfather. So grandfather is like a superclass. It's like a superclass. So you might wonder why it's a superclass, because this is the last base version of the class. So the superclass can also be called as a base class. Okay. So any other classes which comes after the superclass are called as derived class. It's called as derived class. So, or in other words, called as subclass. Subclass. Yeah. So if I want to inherit the property from a grandfather towards the father, or from the base class to the derived class, I have to use a special kind of keyword. The keyword is called as extends. How will the compiler know that he is a child and he should also be able to see the particular values of a grandfather, right? How exactly he sees it? So we have to make him as extended class of A or B, whatever it is. So now we can see here, if I specify A as a superclass, so B is a base class. So B, whenever you create, for example, I have a class B. So B should extend A. That means extends, you just specify over here whenever you're creating the class. So compiler will get to know that yes, I have a class B which is actually extending it from A. So all the information or member variable and member functions of our class A here will be seen from the objects of B also. Okay, let's see in terms of a program here. So very simple program which we have. I have a superclass which is A. Okay, I have A here, so which is my superclass. In my A, what do I have? I have instance variable, right? So these are what? Instance variable, that is I and j. So I and j. So next is I also have a show ij method. So I have a show ij. What about this method here? So this method is actually a member function of whom? Of class A. So I also have a B class which we say that B is extending A. Whenever B extends A, you can also see what I have in A, even though it is private, even though values are private. All right. So I have B extends A. So automatically it will see ij values also. So straight away by using class name also you can get the values. All right. So yeah, I'll tell you how exactly to access these values without even getting to know the values. All right. So without even getting to know is here, it's what we already have, I plus j plus k. So it automatically, the base, the derived class can see the values of A, right? So by this, we can say that we have like a tunnel or a connection between A and B, right? So whatever I have in A will also be visible in B. B can automatically access it, right? So what do I have special in B? B has its own variable, that is k, and you also have two functions, that is show k and sum. All right. So what are these two methods doing here? Show k refers to, he is printing what is the value of k. Initially, I don't have any values, so it will be 0. Next, void sum equal to I plus j plus k. What do I have in I plus j plus k? Any values which I have, that will be summoning up over here. Okay. Major concept is this: B extends A. B extends A. That means derived class extending the superclass or the base class. All right. Next, yeah, we are giving some values here from where? From the main class. So which is the main class here? So simple inheritance is the main class. Anyhow, the execution starts from this point. So I have a main. So I'm creating an object of A and object of B. So I have A, I have B. So automatically A object is called as a super object, and in that super object, what do I have? I have I have j, and I have show ij, I guess, right? So just now we saw. Next, another object which is sub object, which will be of b, and b we have k, and we have some method show k and sum, right? So two functions and k as one variable which we have in this object of b. So this is an object of b, and this is an object of a. All right. So next, what do we have? Super ob dot I is 10. So super ob of I means straight away here with the class object I am providing I value as what? 10 and j value as 20. So similarly, he is just printing. So whenever he prints contents of super ob, then he goes to show ij. What do I have in show ij? Show ij, I'll be printing I and j values. So you can see in the ultimately in the output, the output will be like contents of super ob. So 10 and 20. So 10 and 20 is what it will print. And then I have, why have we used just this? Why? Because just to print a new line. So I have a new line here. Okay. So next, sub ob dot I will be 7, 8, 9. So what does it say now? Sub ob of I, sub ob of j, sub ob of k. 7, 8, 9. Automatically it goes, it erases these values. Okay. So my new value will be 7, and this value will be 8. Automatically k value will be 9. This is the beauty of extended inheritance. All right. So then it prints here the next version, contents of sub ob. So contents of sub object. So what does it do? I and j it will print again. So when you print, which ij it is seeing? 7 and 8. So it will print 7 and 8. Next, print out, println. Okay, next line. Then we have the sum of I, j, k in sum ob. Then I call the sum. So it will print sum of this statement which it prints, and what is the sum of this value, right? So 8 plus 7 plus 9 will be 24, right? So sum, it will print it as 24, right? So let's see the output. Okay, yeah, here it itself is the output. So I have 10 and 20. So whenever you change the value using the object of derived class, those values will also be changed, right? It's like permanent. So no recalling, nothing. So whatever you change, because it can easily see what exactly I have in A or what exactly I have it in B. Any doubts in this particular very simple inheritance? If you have any doubts, you can ask me. All right. If not, we'll move on. So accessing the member variables using the inheritance. So here comes the beauty of it. Okay. So we have members, access, and inheritance. Although a subclass includes all the members of its superclass, it cannot access the members of the superclass that have been declared as private. So there should be some twist, right? So I have class A, and I have class B. I have class B. If everything, whatever I give here, int I, j, then here int k, whatever I have in class A, if it is getting to the extended version of B here, then how can I at least hold few of the information which I cannot show it to someone else? Not even inherited value. Not even inherited value. So there comes our member access. Means, okay, if you do not want to show any member variables which is of class A to any other derived class, make it as private. Make it as private. If you make it as a private, only within that class the variable can be utilized. For example, if I have a variable of x, that x can be seen only within the class. Okay, so that's the program here which specified in a class hierarchy, private members remain private to their class only. This program contains an error and will not compile. Why? Because let us check out why it will not give us that value. So execution starts from main program. So I have a main program somewhere here. Yeah, so before that, do I have any classes here? Yes, I have classes. For example, as I said, I have class A, I and J. So I have I and j, that means, okay, instead of this x here, so it will be j. So this j will not be over here. Okay, j is private. Then I also have set ij. So if you don't want this particular way, this member function also visible to other class, you can always make this as private also. If you make it as a private, this method cannot be visible to other people also. Just for your example, understanding here. So I have class A, class B extending the A. Then what do I have in class A? I have set ij method. So anyhow, it is not private. So set ij. Then A is not accessible here. So I have B extending A in total. So in B, I have, instead of K, it was what? Total. So then I have another method which is called as sum method. So why do I have sum method? It is adding the values. Okay. Yeah, gentlemen, kindly mute yourself. Anu, Prashant. Okay. Yeah. So I equal to x, j equal to y. Before that, yeah, we declared class A, we declared class B, extending A. So we have total, sum, and it is doing these things. So yeah, my class is actually ready. Let's see what exactly a main method is doing. So I have a main method, a main class which is called as access. So in the main class, I'm creating an object of B. So A is not required. Why? Because you already B is actually extended with A. Means whatever A has, B can also see. So B sub object equal to new B constructor. So sub ob dot set ij 1020 automatically, if you know that, okay, this class B can see whatever the contents which have in class A apart from private. So it sees ij and it also sees set ij method also. All right. So what happens? I create an object of B. So B's object, what is the name? Sub object. So sub object. So whenever I create a sub object, automatically the sub objects I and j value will not be there, and total, then sum, right? So some method and something called as, what was the method? Set ij. But it cannot see what? It cannot see the jth value because j is private. J is private. Only objects of A can see it. So whenever you are accessing the jth element, whenever you are accessing a jth element, there comes the issue, right? So here b equal to sub b equal to new b object, setting the object 10 and 20. Okay, there itself comes the problem. So 10 and 20, because sub object cannot see this 12. Here itself you get a compiler error. Before that, here if you have a suggesting compiler, it will tell that j is not accessible here. There itself it will show. Why? Because it cannot see it, as simple as that. So what do we learn from this? If the program will not compile whether the reference to j inside of some method of b causes an access violation, because since j is defined as private, it's only accessible by other members of its own class, but not the subclasses. Okay, so I hope you people now got to see how exactly inheritance works. Yeah, we have some program regarding the inheritance. Same way, I want you people to look into and work on it. If you have any doubts anywhere, kindly you can always reach me. You know where to find me. So next is about the superclass. So there can be cases. The one more bigger example which I wanted to tell is we have some limitation in inheritance. Okay, so we don't have like in object-oriented programming in C++, that is C++, we had many types of inheritance. Like we had multiple inheritance, multi-level inheritance, right, multi-class. hybrid inheritance. Many we had, but we have some limitations in Java. We'll try to understand what are the limitations of inheritance in Java. Before that, we have to understand how about a super, right? So he is also explaining the preceding example. We'll try to understand what preceding example here says. Okay. Yeah, we have a reference demo as a main class. So we have a main method. So we have a box weight weight box equal to new box 3578.37. That means where is this box weight now? I think it is in the previous example. Color box. Okay, so ultimately he is going back to the same program of this thing. Okay, no issues. We'll look into this program. All right. So what do we have? We have a box class, and in the box class, we have three important terms: width, height, and depth. We also have a constructor. What type of constructor it is? It's a parameterized constructor, and here it's an object. Okay, so it is an object copying the constructor. So box of obj ob, so pass object to the constructor finally, how you know. So object dot width, height, and depth will be automatically fixed to the class which has been created. Okay. Next comes, you have some parameterized here, w, h, and d. Okay. So here, if I know the values which I want to specify, I'll send the values of w, h, and d. If I do not know the values, then straight away I can also send the object itself of whom? Of box. So that box width, height, and depth will be copied. That's what the copy constructor which it is doing. All right. So passing object in as towards the constructor. If nobody sends any values, if nobody is sending any values, then automatically -1 will be created or assigned. Then if he is giving only one value, then everybody will be assigned with the same. If okay, then we have a particular member function. So it is a member function. So what it does, so width, height, and depth, it will multiply and it will send you back. So here I have a box weight which is extending box. So this is what the box weight. So now I have a box class. So box class had some stuff. Then I have a box weight class. So it is extending from box. So now it gets to see all whatever I have in box X. Okay, what are the things which it can see? It can see all the constructors. It can see all the member variables, all the member functions, apart from private. Now here, again in box weight also, we have the same instance variables. So I have here weight, height, and what was the other one? Depth. I have what? Depth. Even in the box weight also, I'm having weight, I'm having height, I'm having height and depth. So whenever I create an object of B, whenever I create an object of this box weight, if I access height of it, whose value it can actually see? Whose value it can actually see? Why? Because it sees two copies. Which are the other copies which it can see here? It can see this one copy from here and this one copy from here also, because height is also there in my box base class. So this is my base class, and you have already given the extended keyword. So this height is also actually visible to my object of box height. So there doesn't comes an ambiguity, but still this box height will definitely go and looks it. The first priority is for the same class, right? This priority will be for the same class. If in case he wants to access this particular height, then he should specify a keyword called as super. We should specify a value called as super. That's what here we are doing. So box weight is also having W, H, D, and M. So box here, So whenever I access double volume with this, so if you want to access the immediate higher value, then you have to go for the super. Okay, so somewhere here the example would have been given. We'll try to look into that. So box double volume equal to some volume, it is printing some volume. So weight is this. So if you want to use the super variable, you can use that super, name of the objects itself. If not, you can call using a super class. So whenever you give WHD, even though it is belonging to box weight, right? Box weight WHD. So automatically WHD will not call into its box weight, as you see in this program here. It will not call its method. Here I have this value here, right? So this constructor will not be called. Why? Because I have a super which is specified over it. So who is the super of this box weight? So here it is. Who is the super of box weight? Super of box weight is box. So automatically it will tend to box. And is there any constructor which is accepting WHD? Yes. So automatically this code will be executed and WHD value will be pushed. All right. So if you want to access the values of its super class or its base class, then get to deal with the value of super keyword. All right. So yeah, that's about the super and its uses. We have some example. Then we also have another use of the super keyword here. Before that, I'd like to explain another program so that one of the example program, assignment program, which we'll be looking today, deals with it. All right. So I have, this will be the demonstration of how to deal with the super with respect to the object, right? So yeah, I have a box class, and I also have some constructors in this. So what are the box class here? So this will be the box class. This will be the constructor. So object copying constructor, again with 3 parameter constructor, no parameter constructor. I think the same code has been copied here. Then the same length is also given. If I give only one value, assume that it is a cube or whatever, it's a cube box, because height, depth and length, width will be the same. Then I have the volume. If I'm looking for the volume, calculate width, height and depth and get it to me. So similarly, we have another derived class. So we have box weight, which is extending box, and we also have another weight here, weight of a box. All right. So we didn't have that weight here because width, height and depth is one term and weight is another value which has been added. Okay, so I also have a constructor of box weight. I have an object for box weight here, so I'm just passing object itself to the constructor. If I want to be dealing with any of the previous constructor or previously created object, if I want to copy the same contents, then I go with this way. So apart from that, I also give weight equal to object.weight to its super. Okay, so weight will be equal to object.weight. That means whatever the incoming object which I have, that weight object will be assigned to the existing weight. That means what it does is it only pushes to its value. Then we have a 4 parameter weight box constructor, so which is having width, height, depth and as well as double M is for probably the weight, width, height, depth and weight. Then we have a weight box. So whenever it sees a weight box, you're calling its super constructor here, super class constructor. There's no need of you to give it as box and you're calling it no. So you can use it via the keyword super constructor. What it happens is, whenever you create an empty object of which class of box weight, whenever you create an empty object of box weight, uh, box weight of, let us give it as empty, right? So what it does is, it comes here, no parameter, right? So no parameter means empty object will straight away looks into a default constructor. In default constructor, what does it see? It sees super constructor. Straight away go to its super constructor. Who knows? It knows, the compiler knows who is the super class of box weight. So it is box. Go to box usual constructor. It will come straight away from here to here. Yeah, automatically here. It doesn't have anything. So what it says width as 1, height as 1, depth as 1. Automatically, this box empties width, height, and what was the other one? Width, height, and depth. No, so depth. Automatically, these values will be initialized to 1. But there is a catch. Box weight has another variable, that is weight. Also assign weight as 1. Then it will be completed. All right. So if you have a square box, then if you're creating an object of square box, if it is empty, this way. If it is not empty, then it goes with another classes. So it goes with the another classes. So box weight, double length, and M is for, why is this length? In case if it is a cube, I need only one value. So any value which has been given, automatically super of one value. So what does it do now? Once it sees super, straight away it goes, looks for one variable constructor. So do we have any one variable constructor anywhere? Yes, here it is. So one variable constructor is over here. It calls here. It assigns width, height, depth, and length as everything, and it comes back, and it will also save weight of that particular object as M. So writing it down here, what happens is, if I have some object, best object here is, just check it out, this my cube. That's what it's doing. So my cube, whenever it creates, 3 and 2 is what it is given. Okay, in box weight, it will look for a constructor of 2 parameters, 3 and 2. So do we have 2 parameter in box? Yes. So here 3 will be given and here 2 will be given. So it calls super of length. Again, length is 3. Straight away it goes. 3 value will be going. By the time, what it does here is, by the time the object will be created, by which values? By cube. So my cube will be created, and that my cube automatically box weight of it sees to the constructor of box. So weight will be determined here. So weight equal to M, that will be given, and before that it also looks into the super length, and in super length what are the values which I have? In super length, width is also there, height is also there, depth is also there, which is given by length. So what is that value? Width, height, and depth. Automatically it will be given with whatever value. For now it is 3, right? So example here is 3, it will go reside, 2 will be there as weight. So this weight will be equal to 2. Got it? So this is a beautiful example of working out with inheritance. So here you also saw what is the use of superclass, right? What is the use of superclass? And when we work out with this example, we have many more working values which you get. So we'll look into clearly what exactly each does. So box weight of my box 1 is equals to new box weight of 1, 2, 3, 4. 4 values you are sending. Is there any box weight which is accepting 4 values? Box constructor which is accepting 4 values? Of course here. So what it does? All the 4 values of what? 10, 20, 15, 35. So 10, 20, 15, 25, yeah, sorry, 15, 34.3. So 15, 34.3. Automatically super WHD. So it will go to super WHD, that is here. It saves width, height, and depth, and automatically this objects, this my box will have its values of my box will have its width has what? Width has 20, then the depth as 20, sorry, width as 10, depth as 20, then height as 15, and weight as 34.3. Similarly, new box of 4, same way it will work on it. My box 3 equal to new box weight. That means nothing will be there. That means everything will be -1 in this case. So everything will be -1. So WHD, everything will be -1. Apart from that, if you go look into the constructor, you also have for 0 parameter, width is also made as -1. So even the width is also made as -1. Okay, for which particular object? For this my box 3. My cube, I did it over here. Then my clone is copying the same contents which I have in my box 1 to my clone. So my box, so here what happens is I'll create a my clone object. In that my clone, exactly copy whatever I have in this my clone. So 2 copies, of course, 2 copies. It's not the same copy. So W equal to, it is cloning. So 10, 20, 15, and 34.3 with W, D, and H and weight. Okay. So ultimately, whenever you print it, so whose object matters? So my box 1 dot volume, my dot 1 dot volume will give you. Where is my box? My box is over here. So 10, 20, 15 plus the weight. All right. So volume will be 10, 20, somewhere 300, 3000 will be the value for the first one. 3000 will be there, and its weight is what? 34.3. So 34.3 of my object 1. So similarly, my object 2 is 2, 3, 4. Right? 4 3s are 12. 12 into 2 is 24. 24 and 0.076. So 24 and 0.076. Next object. This is done. This is done. So my box 3. My box 3 is what is it having? My box 3 is a default 1. So -1, -1, -1, -1 will be the value. Okay. Next is my clone. What does this my clone do? My clone is giving you the volume of whom? My clone is a clone of my box. So same way, 3000, 34.3. So 3000, 34.3. Next, my cube. Next, my cube. So my cube, where did it go? My cube, 333. This is a 9 and 3 is a 27. So 27 and 2. 27 and 2. That's how exactly inheritance with the super class works. Notice that super method or a super constructor is passed an object of type box weight, not of type box. Every time whichever object it has been shown from there, it will move to its super class, not straight away with the box. This still invokes the constructor box object as mentioned earlier. A superclass variable can use to refer any object derived from that particular class. Thus, we are able to pass a box weight object to the box constructor. Of course, box only has knowledge of its own members. That means as box is a superclass, base class, right? So for that base class, the own members can only be seen. If box weight wants to see, then it has to go look for box. So let's review the key concept behind here. Super class. When a subclass calls super method, it is calling a constructor of its immediate superclass. Thus, super method always refers to superclass immediately of this thing. So here is a catch. What is that catch means? If I have class A, I have class B, I have class C. So B is calling A, C is calling B. For C, who is the superclass? B, but not A. For B, who is the superclass? A is the one. That's what the statement actually specifies. All right. We'll look into the second use of the other use of superclass and create a multi-level hierarchy. How to achieve that in Java. We'll be looking that in our next class.